Example 1, the chemical formula for water is H2O. If we have 3,600 grams of water, what is the weight of the oxygen? First off, I don't know how many of you have taken a chemistry class or physical science to the extent you know what H2O means, but I always make the assumption students know H2O means there's 2 hydrogen atoms, 1 oxygen atom. If you don't know that, that's what it means. H is hydrogen, O is oxygen. The subscript tells you how many atoms within a molecule of that whatever compound is. All right? And what I want to do here is I want to treat this like a ratio problem. This is the recipe for water. Okay? And you get an H2O, which 2 hydrogens and oxygen, very, very tiny. Okay, it's a little tiny molecule. You get some like microscopic tweezers, pick up one little molecule and look at it. It's got 2 hydrogens and oxygen in it, okay? And billions of those put together make a cup of water. More like trillions or something. It's a lot of them. All right. The molecular weight level of hydrogen and oxygen in a molecule of water is the ratio column of the chart. And they even tell us the molecular weight of each different atom. So every hydrogen atom weighs 1 mole, and the chemical formula says there's 2 hydrogen atoms in the molecule. 2, how many we have, times 1, how much it weighs, equals the molecular weight of the hydrogen within the molecule. O is oxygen. Oxygen weighs 16 moles per atom, and the chemical formula says we have 1 molecule or 1 atom of oxygen. So no subscript implies 1 molecule or 1 atom. So 1 atom of oxygen times each one weighs 16 makes total weight of 16 moles for the amount of oxygen weight. So that means every molecule of water, if we were to pick it up with our microscopic tweezer, stick it on a microscopic scale, it would register as 18 moles. Okay, and this is just like a basic ratio problem. The ratio of pigs to ducks in the barnyard was 2 to 16. How many animals were there if there were 24 ducks? Okay, so you know that's the kind of problem it is. Pigs, ducks, total, right? And so hydrogen, oxygen, total. That's all that's happening on this side. On the other side, as far as actual amount of things is concerned, it says we have 3,600 grams of water. Is water HO or H2O?
H2O.
H2O. So we're going to put 3,600 grams right here in the actual row next to the water formula. And it says what is the weight of the oxygen. So we're questioning how much is that. So we throw out the hydrogen and we're left with a proportion of 16 over 18 equals X over 3,600. And I can cross multiply immediately. I can also reduce if possible. Reduction is allowed vertically and horizontally. Notice 18 and 3,600 divide down to 1 and 200. They both divide by 18 evenly. Okay. You cannot reduce diagonally. You only can multiply diagonally, but you can reduce horizontally or vertically. So once I get this number 1, I can't reduce 1 with 16 or one with 200, so that's it. So 1x is equal to 16 times 200. So we end up with 3,200 grams of oxygen. How many grams of hydrogen would there be? 400. 400 grams of hydrogen, right? So once we find 1, these two should add up to that, so 400 plus 3,200 equals 3,600. In case I should ask for more than one thing, that's how you handle it at that point.